Another way that may help us understand what is continuous is by understanding what is not continuous. So there are a few types of discontinuities that if you understand how they look and their behavior, then you can really understand, or you can narrow down the functions that are continuous from those that are not. The first type, hopefully you've been introduced to before, is the whole or the removable discontinuity. And this is the continuity that comes from the failure of the limit to exist. Excuse me. This comes from the limit existing, but the function at that value does not match up. So in this case, the limit exists because from the left and from the right, I'm both approaching the same value. But at that point, something weird is happening. Either there's a hole or the value is way up here or something. So this is where the limit exists, but f at that function is no good. We call those holes or removable discontinuities. Another type is a jump discontinuity. And this comes from the failure for the limit to exist. Specifically, the left limit is approaching some value, and then the right limit is approaching a totally different value. So the limit doesn't exist, so obviously this is not continuous. And the last type is an infinite discontinuity. And one type of infinite discontinuity is the vertical asymptote, which comes from a limit equaling infinity. Okay, so there's the types of discontinuities that prove that something is not continuous.